Trig, everyone loves trig. We're going to start with this question here. We're given that 2 sine theta is equal to 7 cos theta, and we're asked to find the value of tan theta. Now, whenever you see trig equations, you should always have a few identities floating around in your mind, and the identity that springs to mind here is that tan theta is equal to sine theta divided by cos theta. And so that suggests to me that all I need to do is get sine over cos in here. So I'm going to have 2 sine theta is equal to 7 cos theta. Divide the cos theta across and I get 2 sine theta divided by cos theta is equal to 7. Divide the 2 that way and I end up with sine theta over cos theta is equal to 7 divided by 2, and that is equal to tan theta. There we go. Has been shown. Now, use an appropriate identity to show that this equation can be written as this equation. So again, appropriate identity. And when you look at this, you should notice that there is a sine and a cos, and it's not any sine, it's a sine squared x. So the identity that should spring to mind is sine squared x plus cos squared x equals 1. And this is achievable from Pythagoras. So if I rearrange that, sine squared x equals 1 minus cos squared x. So what I'm going to do is I'm going to substitute in for the sine squared x. So 6 sine squared x equals 4 plus cos x. Substituting in gives me 6 times 1 minus cos squared x, which is still equal to 4 plus cos x. Multiply out the brackets, we have 6 minus 6 cos squared x, and you guessed it, it still equals 4 plus cos x. And goodness knows what that little bracket's doing there. And now I'm just going to add it all over to the side. So I want to end up with 0 here. So I've got 6 cos squared x plus the cos x, and then I subtract the 6, which means I'm going to be left with minus 2, and that is the thing we've been asked to show. And rather expected, we're now asked to solve the equation, and of course we've rearranged it into a form of a quadratic which we can solve. The clue here is the word hence. It's basically telling us that our previous answer is very likely to help us, and they've given us a range. Also, just briefly notice that they've given you the quadratic here, and they've done that because they want you to be able to have a good stab at part 2, even if you couldn't do part 1. So please don't give up if you are stuck at the start of a question, because quite often, if you keep your nerve, you can jump into the question halfway through. So let's get on and solve it between 0 and 360. So the first thing to do is to notice it's a quadratic. The second thing that might help is to perform a substitution. So I'm going to call A cos x. And what that means is I've got 6 times A squared plus A minus 2, and it equals 0. And you might find that's a little less intimidating to factorise than the original. And it does factorise. 2A minus 1 and then 3A plus 2. And that gives us 2 lines of attack here. We could have, and I'm going to substitute the A back now, we could have 2 times cos x minus 1 equals 0. And I've taken this bracket and just turned the A back into cos x. Or we could have 3 times cos x plus 2 equals 0. And each of these will lead to some more answers. So this one here will give me cos x as a half, which means x is the inverse cos of a half, which is 60 degrees. And then over here, cos x would be equal to minus 2/3, and x is the inverse cos of that. And Mr. Calculator tells me that's 131 degrees. Now, of course, I now have to check that I've got all my solutions, and I like to do that by drawing myself a trig graph. Not the only way to do it, but quite a handy one. So here's the cos curve here between 0 and 360, beautifully drawn. There we go, there's the 360. Now, let's do this one first. So cos x is a half, so there's a half there. So along we go, and there's one solution here, that's our 60. And the other solution is there, and that one is, so if this gap from the peak to here is 60, then coming back from this peak, if that's a gap of 60, this must be 300, because this is obviously 360. So it could be 300 degrees. And that's the only solutions within our range. Now the other one, minus 2/3, down here somewhere. So I've got an answer here, which is my 131. And I've got another answer up here. Now this gap here is 131. So the gap backwards from 360 is also 131. And that gives me an angle there of 228. And the reason it's 228 is because I subtracted it from my calculator using the full decimal of this, which is why it's not exactly 360 minus 131. Anyway, got your 4 answers. You might be just a little bit skeptical that you've got the right answers, and obviously that's something that's nice about maths. You can always check your answers. The place I went to check my answers was the equation here that was given in the book, in the question. So I used my calculator, and I substituted each of these 4 values of x into this equation, and checked that it gave me either 0 in these cases because they weren't rounded, or very close to 0 in these cases. And that's how you can check. So I would recommend you do that with at least one of these values, just to put it through your mind how you can check your answers, because it's really, really comforting to know you're going on the right track. Question number 2. Okay, so we have a square of side. Got to have a diagram. Can't do these sorts of things without a diagram. So it's a square is cut from the corners of a piece of card 15 by 24. So 15 by 24. It's going to be rectangular. So we've got our 24 here and our 15 here, and a square is cut from each corner. And the square is of side x. And that means that I can see that this distance here is 15 minus 2 x's, and this distance just here is 24 minus 2 x's. So, that's part I. Show that the volume of the box is that lot. Okay, volume of a box, well, that is, it's going to be a box looking something like this, isn't it? Open topped. So we need the 3 dimensions. So obviously it's going to be x high, so the volume is equal to x. And then we want the width, that's going to be 15 minus 2x. And the length is going to be 24 minus 2x. And when you multiply that all together, you get x times 15 times 24, which is 360, minus 30x minus 48, x plus 4x squared. These two here are going to make minus 78x. And then we multiply through by x, and we get 360x minus 78x squared plus 4x cubed, which is this. Part 2 now. We want to find a value of x We'll make the volume a maximum. And the word maximum is a massive clue in mathematics. Maximum makes you think of curves, and maxima and minima and gradients. And of course you want to do dy by dx and find your turning points. So maximum turning point. So that means I'm going to find, in this case, the volume with respect to x. So how the volume changes as x changes. So I'm just going to integrate, differentiate it. So that goes to 360. This one, 2 comes down, so it's minus 156 times x plus 12x squared. And for turning points, that lot will equal 0, so 360 minus 156x plus 12x squared equals 0. And there's usually a mark for that, for showing you know that, which is one of the reasons you should always show your workings. All these numbers will divide by 12. So that gives me x squared minus 156 divided by 12 is 13, so I've got minus 13x. That divided by 12 is 30, so it's plus 30 equals 0, and this will factorise quite nicely. Always worth looking out for numbers that you can divide through by at this stage. Now, 30 is made of 1 times 30, 2 times 15, 3 times 10, 5 times 6. Now, they've both got to be the same sign, which means I can't have 2 and 15 because I would need a different sign on each of them. So it's 3 and 10, and they're both going to be negative, which gives me two solutions. X is either equal to positive 3 or x equals 10. Now, before we go much further, let's just see how reasonable this is. Now, 3 seems alright, but 10, 15 minus 2 times 10, that's going to give you a negative length. So this one is not a possible solution. Which is nice because it means we only need to consider that one. So we found our value. Now the next thing we are going to do is we're going to just check that it is a maximum. Let's just go back to the question briefly. Okay, so we need to check it's a maximum, and then we're going to give the maximum volume of the box. Right, so to check it's a maximum, we're going to use the second derivative, which is d2v by dx squared, and that's going to, the 360 will disappear. We'll be left with a minus 156, and then this will become plus 24x, and when x equals 3, this thing here, and you don't actually have to evaluate it, you just want to know if it's positive or negative, and you can see that if you do that times 3, it's still going to be negative, so it's less than 0, which means that x equals 3 is a maxima. So that's good. And if x equals 3 is a maximum, then to find the volume, we just substitute into the original formula, which was 3 times, so that's x, and then it was 15 minus 2x, and 24 minus 2x. And that gives you 3 times 9 times 18, which ends up as being 486 cubic centimetres. And there we go. I hope you had fun with that one.